Part 6. Furthermore, what may no longer be needed in physics? Renormalization, gravity and gravitons, gluons, strong force, quarks, cosmic constant problem, missing mass problem, Higgs field, zoo of particles in the Standard Model, string theory, and TOE theory of everything. Some questions left. Why is the proton so stable, and why is an alpha particle or helium nucleus so stable? What is spin? Why just two types? What is the connection to charge? What is entanglement? Why is it connected to spin? What is dark matter? Best guess. It's virtual particles before annihilation, like the entire universe, breathing in and out. Why did the Big Bang start? How did it start? Why does current flow from positive to negative, or does it? What is on the other side of absolute zero? Offbeat speculation. There is a dark zone, Dimp possibly, that may be all these things: black stripes in the two-slit experiment, the node of all quantum waves, the space leaped over in a quantum jump, virtual particles, and vacuum energy. How does approaching the speed of light affect the Casimir effect? Rubber sheet analogy without mass. Quarks are weird if true. Pre-Big Bang and post-universe? Question mark. Compare the ratios. Dark energy is 70%, dark matter 25%, with hydrogen is 73% of the universe, helium is 27% of the universe. The energy of a photon is inversely proportional to the wavelength. Now take a wavelength to its ultimate, a single line, a point, a pulse. Can anything go faster or be more straight? The universe ends as every wave stretches out to a straight line due to dark energy. Conservation of energy says that it is never created or destroyed. Maybe yes, because energy never moves out of Dimp, the dimensionless point. Instead, only particle pairs do. Or maybe no, and dark energy increases the amount of energy in our space-time. But does that increase have an endpoint? The entire universe is just a black hole in Dimp. Virtual particles are the event horizon. Could there be other subset universes that came out of Dimp? If there are not equal amounts of electrons and positrons, we are not here. Did the inflation epoch stretch all the waves in the universe as it expanded rapidly? Non-locality. No such thing as place or distance. Everything tied together in an entangled universe. Backwards in time mixed with forward in time equal now. Positron goes backward in time, electron goes forward. Does that make the original photon, now time, such that positron past plus electron future equal photon now? Or positron electron, the same thing in different directions? Magnet. First I started with a drawing of a photon that converted to a positron-electron pair in a V-shape. Each charge shot off in opposite directions and opposite spin. Then I drew a rectangle around it, equal bar magnet. Question: why don't the two ends of a bar magnet meet in the middle and annihilate each other? If plus attracts minus, why doesn't the charge of a magnet meet in the middle and annihilate? Question: why does the magnetic line circle around the center of a bar magnet? Question: we know the center has less charge or zero charge, so what's in the center? An annihilation zone? Photons? Both? Question: Why would photons be in the middle? Do they generate the charged particles at each end of the magnet? Or are they the result of annihilation of charged particles that meet in the middle of the magnet? This may help explain why there cannot be a monopole, because a photon has to be in the center to produce and power both charges at the same time. Shells in atom alternate direction. Fact: two parallel wires carrying current attract or repel according to direction. Same direction equal attract, opposite direction equal repel. Could that idea transfer to an atom, with each electron shell in an atom going in an opposite direction to the one before it? First shell with 2 electrons goes clockwise. Second, counterclockwise. Third, clockwise, etc. So going further, could electrons be particles going in one direction and positrons in the other? Natural selection in space-time. The Big Bang Little Tear singularity at its highest temperature and energy produced a zoo of particles waves. When temperatures dropped and expansion slowed down, this production stopped. So which ones lasted? Like-minded waves, waves that somehow interacted with other wavelengths, were more likely to form atoms, molecules, etc., such as electrons, protons, and neutrons. Those that were neutral didn't react with anything, such as neutrinos. The rest of the wave particles were short-lived and decayed, or were annihilated with mirror image waves. That may be important clues to every aspect of physics. Natural selection in physics or quantum selection. Temperature. A remarkable feature of the Big Bang Little Tear universe is that temperature determines the relative abundance of energy in matter. It seems reasonable that the Big Bang froze matter waves, particles, at certain temperatures as the universe cooled. What are those temperatures and why those? Quotes. Quote, I think I've just seen how the universe works. Quote, we're entering a state of much more sophisticated confusion. Christopher Stubbs. Quote, any intelligent fool can make things bigger and more complex. It takes a touch of genius and a lot of courage to move in the opposite direction. Albert Einstein. Quote, to be sure, all these theories are speculative, but speculation is as important a part of science as observation and experiment. Richard Morris. Quote, the missing pieces may already be out there awaiting someone to pull them together. It may also take some entirely new idea or the recognition that some old idea is subtly flawed. George Musser. Quote, 1,000 mistakes are one simple concept. Quote, can't fill in the details. No one can at this time. Special thanks to John H. Chalmers for his cantankerous help over these years. Museum number 207, Why? The Psy Phy Physics from a Sci-Fi Writer issue. Copyright 2022 Tom Hendricks. Tom-Hendricks at att.net. Main website tomhendricks.us.